if-else statements. Let's start with an example. The clothes project in our examples. I'm going to run it. What's the temperature? Okay, let's be hopeful. 80 degrees. Wear shorts, get some exercise outside. Okay. Let's try it again. Run the item. What's the temperature? Oh, let's make it colder. 40. Wear long pants, get some exercise outside. Still, this is Fahrenheit, obviously, not centigrade. Let's look at the code. This is just the body of the main simple little program. So I prompt the user for a temperature value. And we start off like we have before with an if. And we have if temperature is greater than 70. And it prints out something, wear shorts. And that's what happened the first time we ran it. It looks just like our basic if statement that we had before. But there is an extra piece added on after the braces here for the clause right after the if. There's an else and another pair of braces with another clause. And this is pretty much like in English. You would probably use otherwise rather than else. If something is true, do this, otherwise do that. The otherwise part, or the else part, you're only going to do if your condition was false. And the second time we ran it, when temperature was 40, this was false. We skipped the part that we would do if the condition was true, and we went on and we did the else part where it said to wear long pants. And once again, this whole combination here is a single if-else statement. And although within the statement there are different patterns of execution depending on the condition, this is just a statement, and the statements of the program go in order. The declaration, the if-else statement, and then the right line statement where it says about exercise. So the point is, the get some exercise outside happens whether or not the temperature is greater than 70. It doesn't depend on this condition. Here's the general syntax. Starts the same as an if statement. Keyword if, condition in braces, and here I show the version with the braces where you can have multiple statements inside the braces, which acts as one statement that is acted upon if the condition is true. But the new part is then there is an else after it, and again it's technically a single statement. I put it here in the form with the braces, which means any number of statements inside of these braces will be done when the condition is false, but not if they're true. Now we go on and say a little bit more about scope. Look at the following piece of code that I give the name bad scope, so you can guess what's coming. If x is less than 100, I want to assign the variable val to more than x. Else, I want to assign to val x minus 2. And notice I've got another declaration here. And we pointed out you shouldn't redeclare things when we've talked before, but actually this if-else statement is legal. The problem is with the return statement that refers to val. The new bit of restrictions that we hadn't mentioned before, that is, if you've got a compound statement that's inside of braces, anything declared inside disappears as soon as you pass out of that block. As a result, this is a form of local scope. This val has nothing to do with this val that's inside of a different block. So that part is actually legal, but it's useless because as soon as you get to the end of either of these, that val ceases to have any meaning. So this val that we're using, assuming we've got a value for it already, we don't, because whichever of these cases we were in, the val ceases to exist when you leave the block. If we put this function inside of a program, we would get an error about this val not being defined. Now, this is a common situation, actually, that we want to give something a value depending on a condition, and we have seen it to be convenient before to declare the variable as soon as we want to use it. This is a case where you just can't do it. Here's a correct approach if you wanted that effect. I declare val just here inside the main function. Then that is still valid inside of further braces. It's declared outside the braces, and it still has meaning inside the braces. This will refer to the same location in memory that was allocated here, and we give it a value x plus 2. And similarly, if the else clause executed, we would give val a different value. Then val that we declared in the main program here still makes sense when we return it. There is even a more subtle situation here than you might have seen from what we've said so far. Consider this variation. This is not usually efficient, but whenever you've got an if-else statement, you could write it as two if statements. Here I've got the same if statement, and rather than having the else statement, I have an if statement with the opposite condition. That's logically equivalent. And so this should have the same effect as the other function. But in order to make this compile, I have an extra change here. I have added an initialization to val up front. Now, as we've discussed before, from the logic of this initialization is never actually used because one way or the other, val is assigned a specific value here first, and then it's returned and used. But let's see what happens in monodevelop if we don't have that equals 0. We are looking at the last function in the OK if scope project in my examples. This is the same thing we have in the notes. Note the equals 0 here. Let me get rid of it. And now let me build the program or try to run it. And whoa, we get an error. It says use of unassigned local variable val right here. Well, we've just explained the logic of how val is sure to have a value assigned there. What's going on? So here's the general idea. For safety, the C# compiler does some basic analysis. It checks that every local variable gets given a value before the value is used. In the earlier function, the OKScope function, there was no one place where val got an initial value, but the compiler is smart enough to see that one of the branches of any if-else statement is always taken, and as we said, val gets a val in each, so there's no problem. The compiler analysis, however, is not complete. It doesn't evaluate any expressions. We did a logical analysis and saw that two expressions were opposite. What they do is good enough to catch many initialization errors, but it's not sufficient in general, as we illustrated with the OKScope 2. Well, you can get into this situation easily, and the original code shows the fix. We need this equals 0. Although we never use that initialization when the function executes, it doesn't hurt, given that it's never used, and that makes the compiler happy. Now, this may seem like a real annoyance that you have to do this, but this is actually fairly rarely occurring, and it is quite common, particularly with beginner programmers, that you forget to give a variable a value before you try to use it. And then most of the time, the compiler will catch that error, and that's really handy. It certainly outweighs the issue of when you have to include this when it is not strictly logically necessary.